Hello. We have already discussed the projections of pyramids in the last classes, and now let's look at the projection of some prisms. I have a couple of prisms here, starting from the first one, which is actually a square prism. For example, having a base edge of 50 mm and an axis of 70 mm, like that. Okay, the main difference between the pyramid and the prism is the prism having a geometry, a polygon in the bottom and also in the top face. Okay, so the first one is a square prism. If the length of the base edge and the height of the prism in the square prism is same, we can call it as a cube. Okay, that means all the edges are of same length, right? Then I have actually randomly placed this prisms on HP, the base on HP condition. The first one is actually one of the base edge is parallel to VP. We can say that one of the base edge is parallel to VP, or we can say that two of the base edges are parallel to VP, which is also same. Or we can say that two of the base edges, this one and this one, are perpendicular to VP, which is also same. Also, we can say that two of the vertical faces of the prism is parallel to VP. That means this vertical face is parallel to VP, and also the behind one, this vertical face is also parallel to VP. Also, we can say that two of the vertical faces, this one is the vertical face is perpendicular to VP. That's also same. Okay, this one and this face, two of the vertical faces are perpendicular to VP. All the conditions are same. Okay, which any of the question ask any of this condition, the symbol position is same. Or if I place the square prism like this, okay, like this, we can say that two of the base edges are equally inclined to VP. Look at that, two of the base edges are equally inclined. In case of square prism, the equal inclination is 45 degree. Okay, two of the base edges are equally inclined to VP, and also two of the vertical faces are equally inclined to VP. Both the cases are same. Two of the vertical faces are equally inclined to VP, right? Okay, then the second one is actually a pentagonal prism. We can count the base corners or the top face corners or the top edges, which is having 5 edges and 5 corners, which is pentagonal prism. The base is pentagon and the top face is also pentagon, and also having 5 vertical faces also. Okay, the first one, the second one, like that, the 5 vertical faces, which is a pentagonal prism. When we're looking at the top position, yeah, we can see the top view of the pentagonal prism like this. Actually, the orientation is random. I place this pentagon as one of its base edge is perpendicular to VP, which is not exactly perpendicular. I meant to place this prism as one of the base edge is perpendicular to VP, and also we can say that one of its vertical face, okay, one of its vertical face is perpendicular to VP. Both the cases are same. Okay, one of its vertical face is perpendicular to VP, and also these faces, we can call all these lateral faces of all the prism as rectangular face. Okay, as the base and top face is pentagon, but the lateral surfaces are rectangle. This one is rectangle, this one, and in the case of hexagon also, all the lateral faces are rectangle or square, and in most of the cases which may be rectangle.